Welcome, everyone. Dr. Schmidt will be here momentarily. It's such a pleasure to be with you. In 2013, I wish for all of you a magnificent year, as does Dr. Schmidt. We are beginning this year's webinar series with 3 special webinars. One, a few of Dr. Schmidt's favorite nutrients, and then some attempt at a demonstration and discussion of the QA clinical protocol. So Happy New Year to everyone, and may this year bring great blessings to you and your families. So let us begin. Welcome, Dr. Schmidt.
Hello, Dr. McCord. Happy New Year.
Happy New Year to you. Today's QA webinar, a few of my favorite nutrients. The QA Distance Learning Program, as many of you know, is designed to allow for home study of QA via DVDs, audio CDs, and the QA book, which is in its 2nd edition. The QA Distance Learning Program is supported by Wednesday webinars that expand the understanding of concepts and principles taught in the QA course, enhance the practitioner's ability to use these techniques taught in the course, and provides an opportunity to ask questions to both Dr. Schmidt and myself. QA webinar recordings are now available online, as you all know, but what you might not know is that QA sessions 10 through 12, 9 QA webinars supporting QA sessions 10 through 12 are also now available as of last week online. So the only ones that we have yet to post are 13 through 15, which we haven't concluded yet. Those of you who are interested, please go to quintessentialapplications.com and click on QA webinars. QA, as you know, is an open system. It's open to all techniques and procedures, past, present, and future. With AK testing for nutrients, for phytonutrients, even medications, we penetrate our patient's physiology and provide a specificity of therapy compatible with each person's needs. QA uses this manual muscle testing response as a somatic window on neurologic function. It's the common clinical approach in all healing professions to look at the patient's local complaints as the primary focus of the initial clinical assessment. However, the QA clinical protocol revises this focus by insightfully approaching patients presenting complaints as an integral part of their overall physiology. It assesses and treats physiology gone wrong in a systemically oriented, logical, efficient, and clinically rewarding manner. Most clinicians in all professions first look locally, and then subsequently, if response is not forthcoming, look at systemic issues that might influence the local symptom manifestation. However, people who are trained in quintessential applications, quintessential meaning ideal, applications means clinical applications. It refers to clinical applications. So the ideal clinical application, which we do our clinical process, we address systemic issues first, which drive local symptomatology, and then address local issues. The order in which you form your techniques may be more important than the techniques themselves, for it is accomplishment of a physiologic task in an ordered fashion that needs to be achieved. However you accomplish that physiologic task, it makes no difference. But you must accomplish it. QA encourages favorable outcomes by addressing systemic phenomena prior to treating local problems. Certain nutritional needs are encountered more commonly in clinical practice. The QA protocol assures the identification of these needs by redundancy of testing for these substances. So when the QA clinical protocol is followed, the optimal time to employ a specific therapy or provide a specific nutrient will be revealed and the underlying cause resolved. Quintessential Applications is the curriculum is available for your requirements, CE requirements, for a diploma in nutrition, sponsored by the Department of Integrative Medicine, the University of Miami Miller School of Medicine. All QA proficiency requirements must be fulfilled prior to receiving these CE hours for diplomate nutrition status. And the doctor must pass an examination for level 1 and level 2 proficiency. There's 180 hours of ACBN credit available through distance learning using QA as that process or vehicle for part of the 300 hours required by and for ACBN diplomate status. Level 1 and level 2 proficiency requirements in quintessential applications: attendance at or verified ownership of DVDs, QA sessions 1 through 7, level 1, and 1 through 15 for level 2. Verified ownership of the QA book and QA CDs, passing of a brief practical exam for level 1, including muscle testing and fundamental procedures, or verified successful completion of an ICAK-approved basic course or an ICAK-approved muscle testing course. You must write 2 brief case reports, IRT stories, injury recall technique stories, 1 paragraph each. You send these stories to Michelle at aksp@theuplink.com and include a statement of permission to use. After all requirements are fulfilled, the doctor is eligible to sit for written examination covering sessions 1 through 7 and the QA audio CDs. For level 2 proficiency, all of those things for level 1 must be fulfilled. Then 2 additional case reports, a brief, interesting case story, 1 paragraph, and then a longer case history, maybe a page, following a patient's progress for at least 3 office visits, demonstrating the use of the QA clinical protocol. We send, again, those case studies to aksp@theuplink.com with permission to use. After all these requirements are fulfilled, the doctor is eligible to sit for written examination, covering sessions 1 through 15 and QA audio CDs. There are 2 more webinars scheduled for January. The QA clinical protocol will be discussed in detail on January 23rd. Now, these webinars this month are being created for public consumption, so they will be available to all of you for review in the future. We're going to discuss the QA protocol and it's the thought process that drives the application of these clinical procedures. And then on January 30th, we're going to do something we have never attempted before, and that is demonstrate the use of the QA clinical protocol on a specific patient. Now, there may be some challenges with that, and we'll find that out, but it should be an exciting January for all of you and all of us. The QA webinars in February 2013, supporting QA session 14 at noon Eastern Time on Wednesdays, February 13th, 20th, and 27th. Mark your calendars. This will be session 14, parts 1, 2, and 3. Today's QA webinar, a few of my favorite nutrients, but before we go on, if you have any particular questions, comments, or cases to share from QA sessions 1 through 13, type them in the question area or ask to talk. So there is any success or pattern with QA with tinnitus?
Well, I would like to hear you kick in on that, Kerry, but I've seen quite a few cases of tinnitus. Some people call it tinnitus. I'll call it tinnitus, ringing in the ears. I've had patients who came in with it and left without it. I've had patients who came in with it, 3 weeks later it went away. I've had patients who've been coming to see me for years and it hasn't changed at all. So it's really a variable thing. I will tell you, I was teaching a seminar in Europe at one time. It was a small ski seminar that we had taught back in about 10, 12 years ago. And there was a woman who we happened to meet on the ski slopes from the United States, and she actually had her husband, and we met, and the husband had tinnitus for like 3 years. And when that seminar, we were demonstrating how to do a number of different clinical procedures, and we ran out of subjects, and we ran into them on the street, and the fellow who was organizing the seminar invited them to come over to the seminar if they wanted to be examined, because we needed more guinea pigs, so to speak. And they came, and I treated the woman and got rid of her paresthesias that she'd had in her arm for like 7 or 8 years. And then the man had tinnitus, and he'd had it for I forget how many years, and we treated him. We got 95% of it to go away right there. Why do we do that? Basically followed what is now called the Quintessential Applications Clinical Protocol. So there are sometimes dramatic and immediate results, and the result of that was that we were able to see 2 dramatic changes on basically new patients and on 1 treatment. That's what you can do. Now, obviously, they don't all respond to 1 treatment, but that couple, both of them who came to volunteer to be treated as sort of demonstration subjects, one of them had tinnitus, and it was like 95% gone. I happened to meet them on a bus a couple of days later, and it was still gone. So those are the kind of things you can have, but sometimes they're just almost impossible to get to go away. It really depends on the cause. Short question, long answer.
And my experience clinically is similar to yours in that regard. Sometimes very quick response, sometimes delayed, sometimes difficult, if not impossible, to resolve using at least the procedures that we know, which are pretty powerful. There is one other question that was asked, and it was regarding a comment that you made about basil and marijuana use. And maybe you can make a brief comment regarding that.
Well, our friend Brent Davis, who owns and operates the Phytotherapy Research Labs, PRL, in Tennessee, Brent had done some research a number of years ago, a good number of years ago, on patients who had chronic marijuana over usage, and found that they had some toxicity from that was helped by basil. And then he produced, with his PRL company, produced a basil product which he would recommend to be used to help people detoxify. That's basically where that came from, and that's the gist of it.
Very good. Today's QA webinar, a few of my favorite nutrients. Dr. Schmidt,
Sir?
The floor is yours.
Thank you. So what are we going to talk about? A few of my favorite nutrients. Well, how do you pick a few favorite nutrients? But I do have a few favorite ones, and I actually limited this presentation to a vitamin, a mineral, and an amino acid. I have a few other ones. I have a favorite antioxidant, and I have a favorite herb, and so on. But we're going to talk just about these 3. These 3 show up a lot in the QA clinical protocol. Folic acid at QA step number 8B, when we look for folic acid, B12, and iron for anemia-type issues and blood carrying capacity of oxygen. 9 through 11, because it's so important in the immune system. Step 19 has something to do with liver detoxification, and various other steps. Molybdenum, same thing, numerous steps, and notice including 19. And cysteine, also various steps, including 8D, which we deal with joint health and things like chondroitin and sulfate and healing the joints, and also 19 for liver detoxification. So you'll see that these steps have something in common, which is basically they have to do with detoxification and certain neurological pathways, certain biochemical pathways that also have neurological effects. So let's start with my favorite nutrient, folic acid. This is probably my very favorite nutrient of all time. Folic acid, 5-methyltetrahydrofolate, its activated form, 5-MTHF. At least 30% of your patients have a need for folic acid in one form or another. It might be 40 or 50, depends what kind of practice you have. But people coming in, regardless of what they come in for, about at least 30% of your patients will have a need for folic acid. And this is why I call folic acid the most important nutrient, maybe. Why? Because look at all the things that it does. Just we're going to cover a few of them. It has effects on neurotransmitter synthesis. Any methylation reaction, including homocysteine problems. Anytime you want to move a methyl group around, folic acid is necessary to move a methyl group, a CH3 group around. And this is important, of course, in homocysteine metabolism, which we'll relate to a little later throughout this webinar. And the need for folic acid, then, in these 2 effects, because of its neurotransmitter effects and because of its relationship to methylation and homocysteine, which also has neurotransmitter effects, its need will contribute to what we call brain on fire, or inflammation in the brain, which we'll address just briefly as we go along. It's a whole topic of a whole seminar, which I may do down the road a little bit, but in a paper that I'm going to present at the ICAK meeting next summer. But this is extremely important for many brain and neurologically related issues. So even if a person doesn't have any brain symptoms, they can still have pathways in their brain which are overfiring, and you can never seem to get them better because of a need to calm the brain on fire, put the fire out in their brain, to cut the inflammation or overfiring down in their brain. Energy and immunity, red blood cell production, white blood cell production, dependent on folic acid. You won't have adequate red blood activity, or you won't have adequate white blood cell activity to carry your immune system messages out if you don't have adequate folic acid. A deficiency creates switching. Just from a pure AK point of view, you get the neurological disorganization of switching, and there's a folic acid deficiency. A lot of times this will be manifested in the hyoid, and sometimes very early on in the treatment you need to check. That's actually part of step 9. Check 9D, check the hyoid, right and left in different directions, and if it weakens, one of the things we see is a need for folic acid. So if things don't seem to be proper, as far as the apples line up on one side and the oranges on the other, there's a switching type of a problem. Look for folic acid and check the hyoid. Folic acid is necessary for DNA synthesis, necessary therefore for tissue growth, for tissue healing and repair of all tissues, especially the GI tract epithelium, since the GI tract turns over so rapidly. Every 1 to 2 days, the lining cells of the GI tract get recycled, and we need new ones, and we have to have folic acid for that. Also then for DNA synthesis, prevention of neural tube defects, cleft palate and spina bifida, for example. Many more essential functions. I'm just reviewing a few of them here. So what are the neurotransmitters that are dependent on folic acid? Well, the common neurotransmitters that you see listed, those that are listed in yellow, glycine, taurine, dopamine, epinephrine, norepinephrine, the catecholamines, serotonin, the indolamine, and histamine are all dependent on folic acid for either their synthesis or their breakdown or both. So what we got to recognize is that if we have a deficiency of folic acid, our sensory receptor-based treatment of a patient, that means manipulation, that means rubbing, pushing, adjusting, the manipulative things that we do on patients where we stimulate sensory receptors. Sensory receptor-based treatment of folic acid patient of a folic acid deficient patient is asking the nervous system to respond to the therapy without adequate neurotransmitters to carry the message you send. Without, as we say, enough water in the hose, without enough neurotransmitter to carry the message. It's a futile effort at best. As I say, 30% of your patients are going to show need for folic acid. It's a huge, huge factor in maintaining the corrections that you want to produce. Now, also we have homocysteine-related methylation problems, and the nutrients for metabolizing homocysteine are listed below, but you see the top of the list is folic acid, 5-methyltetrahydrofolate, in its activated 5-methyltetrahydrofolate form, and also B12 in its methyl B12 form. We'll talk about that more a little bit in a second. When folic acid in its 5-MTHF form, its activated form, is unavailable, homocysteine conversion is impaired, and what happens is homocysteic acid is produced, and homocysteic acid is an excitatory neurotransmitter. So if we look at the sulfur amino acid metabolism, we see it starts with methionine at the top, comes down to homocysteine, which is circled, and then circles back around to the left using folic acid, B12, and a methyl group to methylate homocysteine into methionine, and then it goes down into SAM where you see S-adenosine methionine gives off a methyl group. So this cycle here from methionine down to homocysteine back around to the left up to methionine is how we give and take methyl groups in our body. If there's a blockage because we don't have enough folic acid, for example, then homocysteine is converted into homocysteic acid, as you see off to the right. This homocysteic acid is a very powerful substance, and it's an excitatory neurotransmitter. That means it turns things on in the brain. It turns things on so strongly that it becomes a neurotoxin, and it summates with or adds on to the effect of aspartate, or aspartic acid, and glutamate, or glutamic acid, which are both also excitatory neurotransmitters and work at receptors that are called NMDA receptors in the brain. And so what happens is if you have aspartate firing and glutamate firing, and then you add homocysteic acid firing, it stimulates these NMDA receptors and methyl D-aspartate receptors and fires those receptors off to the point where you overfire the cell. Now, when folic acid in MTHF form is unavailable, and this is true also of B12 and B6 and methyl donor, when these things are unavailable, homocysteic acid is produced. This excitatory neurotransmitter adds to the overexcitation of these NMDA receptors, which are already being stimulated by aspartate and glutamate, and this drives people to neurological symptoms, including things like seizures. Okay, but what about anxiety? Yeah, anxiety too. Depression, yes. Bipolar disorder is almost always seen associated with people who are overstimulating with aspartate or glutamate, and if those pathways are overfiring, and if homocysteic acid is added onto it, it just aggravates it even worse. ADD or ADHD, attention deficit disorder, attention deficit hyperactivity disorder. Yes, these are the aspartic acid glutamate pathways which are overfiring once again, and which overstimulate pathways in the brain that cause these overfiring for both physical seizures and emotional anxiety, depression, bipolar, and combination of both ADD type patients. So overexcitation when there's homocysteine acid can overstimulate these cells even to the point that it causes the neuron cell death. It overstimulates it, it whips it to death, so to speak, and you get neuron cell death by apoptosis. Now, I see a lot of patients like this. I see a lot of neurological patients. I see a lot of emotional patients, and so many of them have this problem with folic acid. So in a folic acid deficiency, you get excess aspartate or aspartic acid or glutamate, glutamic acid receptor activity. These receptors, the NMDA receptor, if you get the excess aspartate glutamate receptor activity without the benefit of all the other folic acid neurotransmitters to counteract it, then you got this brain just firing. You don't have the serotonin to calm it down or the dopamine to calm it down or whatever other neurotransmitters are dependent on folic acid. If they're not there, then this pathway just causes the brain to overfire and causes more brain on fire, as we talked about. So the 5-MTHF activated form of folic acid depends on 5-methyltetrahydrofolate reductase. This is an enzyme that's genetically controlled. And the gene is called 5-methylene tetrahydrofolate reductase. And the gene, a SNP, a single nucleotide polymorphism, that gene causes decreased conversion of food-type folic acid into the 5-MTHF form. And up to a third of the population has one or no of these genes. And this is about 30% of your patients that don't even convert, much less if they have enough folic acid in their diet, they can't convert it to its active form. Now, 10% have no 5-MTHFR genes, which means they can't convert it at all. And there's another gene that can also back up the folic acid conversion. We'll talk about that in a second. But if you look at the genetic activity of patients, 7.2% of white and 18.2% of Hispanic and 3.8% of Asians in the United States have no 5-MTHFR gene activity or one of the genes, and that means that they cannot make this active folic acid, and they're under jeopardy all the time for these problems we've been talking about and many others. So it is, fortunately, supplement responsive. So dietary folic acid and gets converted by this enzyme, 5-methylene tetrahydrofolate reductase, into 5-MTHF, its active form. So the dietary form gets converted to its active form, and this is dependent on genetic activity. 30% of people do not have adequate genetic activity. 10% have no genetic activity to do that. So this form of folic acid, you can perform lab tests for these single nucleotide polymorphisms, or these SNPs. There's a polymorphism called a C677T gene and an A1298C gene. You can do this at major labs like LabCorp has this available. It's by about $150, $200 if you go through professional co-op, a similar type of a discount lab. Roughly 30% of your patients have SNPs and produce suboptimal amounts of 5-MTHF, but fortunately it is diet, that is to say supplement responsive. Now, how do you find out a patient who needs activated form of folic acid? Well, identify a weak muscle, including a hyoid challenge right or left, causing a strong muscle to become weak. Test a typical form of folic acid. Try to get without any B12, one you'd use in your office. Then test the 5-MTHF form of folic acid, again without B12. Or if you test one that has B12, make sure it has the same kind of B12 in both samples, because what you're trying to do is see if there's a difference between the typical folic acid and the 5-MTH form of folic acid. And if the 5-MTH form strengthens and the typical form does not, this suggests a problem with folic acid conversion, a problem with a SNP in this 5-MTHF reductase gene, and we must supplement 5-MTHF. This is the most common supplement I use in my office is 5-MTHF. Now, a variety of sources of 5-MTHF, I've listed a few of them here. I'm not trying to push one company over another, but there are a number of companies now in the last few years who have come up with these substances. I'll tell you, though, you may have to test more than one. I have maybe 8 different substances that I can test in my office, and what I find is if I test, say, Folapro, maybe it works on one patient, but it doesn't work on another patient. Then maybe I test the 5-MTHF on one patient, it works on a different patient, but Folapro doesn't. So because of the different ways these are produced, the different binders and fillers maybe, I'm not sure exactly why, but I test at least 3 of these substances on each patient to make sure that they're not getting a reaction to one of the fillers or binders, or maybe the way that the 5-MTHF is processed in one product is different from another. So you'll miss this if you only test one type of 5-MTHF. So get 2 or 3 of them at least in your office and check not just one but several if you're trying to identify a need for this 5-MTHF, because oftentimes they won't all be positive. Only one of maybe 2 or 3, if you test them, will be positive. Talk about folic acid and B12. Well, B12 is not one of my favorite nutrients, but you can't talk about it without also talking about folic acid. So they never should supplement never should supplement folic acid without determining a B12 sufficiency. Now, that doesn't mean you have to supplement B12, but you have to make sure the patient has adequate B12 in their diet and they're having adequate absorption and so on. You can use muscle testing to determine different types of B12 also to see if the patient has any need for that. B12 deficiency can be masked by folic acid supplementation. And the way that works is if a person's anemic because of folic acid deficiency, the anemia can be covered by giving, by B12, I guess I should say, because of B12 and a folic acid deficiency together. You could supplement folic acid, kind of jumpstart that, and a lot of their symptoms of anemia will go away. They'll feel better. But if the B12 deficiency is untreated, that untreated B12 deficiency can result in irreversible neurological damage called subacute combined spinal cord degeneration. This has symptoms kind of like some MS-type symptoms, and it's basically irreversible, and it's from B12 deficiency. And it's why most folic acid supplements also contain B12. Well, you can give patients you can give patients folic acid without B12, but you must determine their B12 sufficiency. When you give B12 too, there are different forms of B12. Which one are you going to use? Cyanocobalamin, hydroxycobalamin, adenosylcobalamin, methylcobalamin. Here's how it works. Cyanocobalamin is the typical form you find in foods. It gets converted in the body to hydroxycobalamin. That further gets converted to adenosylcobalamin and on to methylcobalamin. Now, there can be problems or blockages in any one of these steps of conversion. So a patient might need maybe just methylcobalamin or maybe just hydroxycobalamin. So we need to have different forms of these B12s to test to get the most effective response on a patient. So let's take an example. A patient who has maybe an elevated mean corpuscular volume, which is associated with either B12 or folic acid deficiency. Does the patient need B12, and if so, what type? Cyano, hydroxy, methyl, or adenosylcobalamin? Do they need folic acid, the typical form, folacin, or folinic acid, a different form of folic acid which is available, or the 5-MTHF form? Which do they need? How do you know? Does the patient need B12 or folic acid, and what types? How would a clinician ever figure this out for each patient's individual needs without manual muscle testing and indicator testing? This is where we have tools with muscle testing and then supplemented by indicator testing, which put us far ahead clinically of all other clinicians. Everyone else is just guessing. I do not understand why people don't see this concept. Everyone else is guessing at these fundamentally important nutrients, taking pot shots and missing the bullseye many times, or missing the ball many times. So with muscle testing and indicator testing, we have measure, measure, measure. Indicator testing is measuring something associated with the patient's problem. Measure, measure, measure. Measure step 3 in the QA protocol. Measure something before and after. These are important tools in the decision-making process of what to do for a patient when confronted with a number of different alternatives, such as folic acid and B12. And we need to do this, and all clinicians should do this, but for some reason or other it seems to be, well, let's just try this one and see what happens, which is not to the patient's best interest. Finally, folic acid in the QA clinical protocol. Well, there are many steps we can find in the QA protocol where folic acid will show up. Food allergies, the bleach sniff test, the other folic acid B12 in step 8B where we test for it routinely. Chondroitin sulfate can implicate folic acid. Switching, as we mentioned, the hyoid and other immune system issues, and then also liver detoxification, step 19, both for endocrine and in general liver detoxification. So a bunch of different places folic acid pops up. Why put it at the top of my list of my favorite nutrients? Now, the second of my favorite nutrients is my favorite mineral, molybdenum. Well, what about molybdenum? Let's talk about molybdenum. We'll talk about molybdenum and iron and copper, and we'll talk about molybdenum as an essential element for metabolizing aldehydes, which are odors and fragrances, sulfites, and ammonia. Now, each of these implicates other important metabolic pathways. So we have a need for molybdenum. It opens up the door for us to investigate other pathways, as you'll see as we go along. The quintessential applications, systemic nutritional factors, those things we look at first, looking systemically first and then locally, involving molybdenum include inflammatory processes, problems processing aldehydes, bleach, or ammonia. These are the 3 sniff tests we do in session 15 in our step 7. Fatigue because of an anemia, which can be related to ammonia, or fatigue because of toxicity related to, anemia related to molybdenum, or toxicity related to ammonia or these other substances or detoxification issues. Doesn't have any effect on cholesterol as far as I know, but also has a significant effect on joint health. So it's a huge mineral as far as importance, and many people are deficient in it. So systemic factors involving molybdenum are anemia, heavy metal toxicity will bump anemia, bump molybdenum and cause anemia and other issues. Free radical pathology, reactive oxygen species. Sulfur amino acid metabolism because molybdenum is necessary to produce sulfate, as we'll see, and that's necessary for liver detoxification. sulfation, and also for the homocysteine pathway, and then joint health and repair also. There, the sulfur, chondroitin sulfate, for example, and ammonia metabolism. Hugely important nutrient, essential nutrient, which if you don't have, you will die. That's what essential nutrients are. So molybdenum and iron and molybdenum and copper, let's say a word about that. Molybdenum and iron are found together in many biological pathways, in plants and bacteria as well as humans. Many enzyme systems use them both. So as far as in humans, our clinical observations over 25 years suggest that there's an iron deficiency type anemia, but it's an iron deficiency non-iron responsive anemia that responds to molybdenum. This has actually been reported in the literature elsewhere more recently. Anytime you test iron, especially if you have an anemia patient, if you don't find iron, test molybdenum. It will have the same effect as iron in a percentage of your patients. Smaller percentage than iron, but the same effect in some patients. We look at molybdenum and copper now. Copper is also necessary for red blood cell production, but copper and iron are in balance. If you have too much copper, you will deplete your iron. Similarly, copper and molybdenum are in balance. So you have to have a balance between copper and iron, and copper and molybdenum. And molybdenum and iron, they all have to be in balance for red blood cell production and for other functions in the body. If we have like too much copper, it weighs down the scale, we don't have enough molybdenum, and vice versa. We can actually fight copper toxicity by using molybdenum. So copper and molybdenum are on a teeter-totter, and we can use copper toxicity. In patients with copper toxicity, we can use molybdenum to help balance that as well. Now let's talk about these other essential pathways that molybdenum is necessary in metabolizing, the aldehydes, which are basically odors or fragrances, sulfites, and ammonia. Molybdenum is an essential trace element. We require it for life. 3 essential pathways, 3 enzymes. We're going to talk about each one. The first one, aldehyde oxidase. Well, what happens if you can't metabolize acetaldehyde? Acetaldehyde is an acetyl group, 2-carbon group with an aldehyde end on it. So it's acetaldehyde, and it's produced in the body normally in normal metabolic pathways. It's also produced by yeast, by candida and fungus activity. The inability to metabolize aldehyde will cause flu-like muscle aching symptoms and a pseudofibromyalgia in some patients. You have difficult patients who are aching all the time. Sometimes it's been diagnosed as fibromyalgia, but it's really not. It could be a molybdenum deficiency with this acetaldehyde building up in the body. Patients will get a mental sluggishness from this toxicity as well. And they'll have a tendency to have recurrent candida or fungus or other gut problems associated with that, because when the body has candida or other molds or fungi, there will be a production of these substances of acetaldehyde, and we need a molybdenum to counteract them. It will also make your patients sensitive to odors and fragrances. They won't be able to go into stores or malls, or new furnishings or new painting in your house will set them off. And many painters, in fact, have a need for molybdenum, whose professions are painters. They need molybdenum and usually other antioxidants because of the effects of this acetaldehyde creating some free radical effects. So it's very important in odors, fragrances, and redecorating a house. Just as humans give off carbon dioxide and water as metabolic byproducts, fungi, that is yeast and molds, including candida, eliminate acetaldehyde as a metabolic byproduct. So acetaldehyde is toxic and must be metabolized to the non-toxic acetic acid. Molybdenum is necessary to metabolize aldehydes. These are fragrances and odors. And molybdenum and aldehyde oxidase, as shown in this pathway, where acetaldehyde made in normal metabolic pathways, but also made by fungi, yeast and mold, including candida, require molybdenum and iron, here they are together in nature again, to produce acetic acid, a very non-toxic and very useful substance that we need. Vitamin B2 and vitamin B3, that is to say riboflavin and niacin, are also necessary for this conversion. The aldehyde sniff test is something we discuss in QA session 15. It's also in QA manual step 7. And in this test, we test for aldehyde and see if the patient needs molybdenum or those other nutrients. Now, molybdenum is this essential trace element also for sulfite oxidase. Sulfite oxidase is, again, coming back to the sulfur amino acid metabolism pathways, and you start to see some overlap in what we talked about before with folic acid. When we get down through past homocysteine, we get into the amino acid cysteine, and following down to the right, we get to where we get sulfite produced, sulfite SO3 produced. This requires the enzyme sulfite oxidase to detoxify sulfite into sulfate. Sulfate, which is so useful for many pathways in our body. If we don't have molybdenum, we can't make enough sulfate. The importance of sulfate, it's necessary for cartilage production and repair. Chondroitin sulfite, for example. Sulfate, for example. And liver detoxification of steroid hormones aspirin, acetaminophen, and NSAIDs, and other substances as well. So let's give a case now. I just had this recently, this week in fact. This 58-year-old nurse came in to see me, who I see periodically, and she had got the flu. The flu's going around. She'd gotten the flu, so she took a bunch of acetaminophen to control her temperature. Her temperature had gone up about 103.5, and she didn't like it, so she took a bunch of acetaminophen and to lower her flu-related temperature. As she came in, one of her symptoms was paresthesias and a drawing feeling in her hand, like her hand wanted to close. Now, her hand didn't have any motor activity where it was actually closing, but it felt like it wanted to close. There was a tightness in her hand. And paresthesias down her right arm. And she gets this periodically when the paresthesias at least, but not the drawing feeling. But she gets this if she eats something she's allergic to or something. So it's a common symptom for her. But in this case, it wasn't from something she was allergic to as such. It was from a liver problem where she had involvement of the liver, and she had a deficiency of L-cysteine, and the L-cysteine was not was strengthening her, but the L-cysteine was only part of the problem. The real problem was she needed more sulfur to be able to produce sulfate, and she needed molybdenum to produce the sulfate from sulfite, that same pathway we just talked about. So we supplied her with molybdenum and did injury recall technique to the Chapman's reflex to the liver with acetaminophen, and her symptoms went away. And we see that in patients who have excess acetaminophen or sometimes aspirin or ibuprofen, all have sulfation necessary and may require cysteine and or molybdenum to provide that sulfate molecule to get rid of those effects of those medications, and many other medications as well. Most medications, most common medications, one of the most common things you see is a breakdown necessary requiring sulfate. So here we see the synthesis now of cartilage, chondroitin sulfate, and other glycosaminoglycans. We see it starts with glucose. We finally get down at the bottom of the page to chondroitin. What does it require? Another sulfate molecule coming from that pathway requiring molybdenum we just talked about to make chondroitin sulfate. So if we have any patients with any joint problems, we have to consider molybdenum as well. Liver detoxification, phase 1 and phase 2. Phase 1, most molecules go through phase 1, and then they go through phase 2. Sulfation, a very important pathway, phase 2 pathway substance to detoxify substances and make them water soluble and get them out of the body. So steroid hormones go through this pathway. In phase 2, they require glucuronic acid and sulfation. Sulfation, then, it shows you how a candida or yeast problem could cause decreased molybdenum, and this candida yeast problem could cause decreased molybdenum, decreased sulfate availability, inability to detoxify hormones, and this is a way you could see how candida yeast could contribute to hormonal problems. And so a patient might come with a hormonal problem, but you've got to look for molybdenum, and you're going to follow the QA protocol to get you to the proper point in that pathway. Similarly, this patient who came in, the nurse who had the problem with excess acetaminophen, depleting their sulfur reserve and needing more molybdenum, she had a hand problem. If someone came in and looked at her hand problem, they missed the boat. You need to look systemically first, then look locally and follow the protocol down to the point of where you get to the local problem, and it will respond quite dramatically. And this patient who had the hand problem, by the way, the nurse with the excess acetaminophen and the molybdenum deficiency, she did not have any local treatment to her hand or wrist necessary at all. Her symptoms completely went away when we corrected the liver with the acetaminophen. Now, homocysteine implicates 3 of my favorite nutrients: folic acid, molybdenum, and cysteine. You see, we've already talked about folic acid and molybdenum. We've also mentioned cysteine. So all 3 of these are necessary to look at when we have a homocysteine problem, which causes so many issues. And we'll talk about that in a second. Here we see homocysteine. We see upper left folic acid, below it cysteine, and lower right the molybdenum again, as we've seen before. Elevated homocysteine is an increased risk factor for cardiovascular disease, Alzheimer's disease, Parkinson's disease, other neurodegenerative diseases, because of that brain-on bioactivity. And I've seen it also involved with so many other emotional and mental issues as well. And also it's a risk factor in the literature for cancer and some kinds of cancer. So the nutrients we need for metabolizing homocysteine, folic acid, and again, we're going to test molybdenum associated with that pathway. If there's a problem with homocysteine, there's a darn good chance there's going to be a problem with sulfation. We need molybdenum also. Let's talk about xanthine oxidase, also dependent on molybdenum. We see the purines in the body, which contain 4 ammonia groups per purine molecule. 4 ammonia groups per purine molecule are broken down into hypoxanthine. Hypoxanthine then is under the influence of the enzyme xanthine oxidase converted to xanthine, and then again the same enzyme converts xanthine to uric acid, and by uric acid we eliminate 4 molecules of ammonia with every uric acid molecule that we eliminate in the urine. This pathway, the xanthine oxidase, is dependent on both molybdenum and iron. We don't have enough molybdenum, we can't get rid of our ammonia. What happens then? Well, we don't metabolize ammonia, we need other nutrients as well. But the ammonia sniff test that we challenge for that is discussed in QA session 15, which is step 7 in the QA manual, and we'll talk about that in those times in greater depth. But what happens if you have too much ammonia? Well, one thing is you get water-holding effects. Too much ammonia can cause premenstrual syndrome. Too much ammonia can cause swollen ankles. If you can't break the ammonia down and can't get rid of it, then you get these water-holding effects. Similarly, neurotransmitter effects creating anxiety or nightmares or mental sluggishness, confusion happen when ammonia builds up. Now, why does that occur? Well, the neurotransmitter effects of excess ammonia are due to ammonia converting one neurotransmitter to another neurotransmitter. And I'll show you this. Glutamate, the excitatory neurotransmitter we've already been talking about, can get converted either into glutamine to the right. If there's excess ammonia, it will drive glutamate to glutamine. However, normally glutamate will get, under normal circumstances, with adequate ammonia and adequate ammonia metabolism, will get converted to GABA. Now, glutamate's this excitatory neurotransmitter we talked about. GABA is the major inhibitory neurotransmitter in the brain. And so we have too much ammonia, we get all this excitation and not enough inhibition. So the excess ammonia drives glutamate into glutamine. Instead of into GABA, we still have the glutamate present, but no GABA to turn off the anxiety, turn off the depression, turn off the seizures, turn off the whatever it is. And here again, molybdenum is one of the players in this with a number of other nutrients that cause the body to get rid of ammonia, so we can get our GABA to be produced. In folic acid deficiency and in molybdenum deficiency, you get excess aspartate and glutamate activity, plus decreased GABA activity in molybdenum, and this again leads to or contributes to the brain on fire, the overfiring brain, the overfiring pathways that we see so often in so many different symptoms in patients. Many times they don't even complain of brain symptoms. Sometimes they complain of fatigue. A lot of patients who have fatigue actually have their brain on fire. The brain is overfiring to the point of exhaustion. They feel tired. They think it's their ileocecal valve. They think it's their adrenals. They think it's their low blood sugar. And what you find is their adrenals are okay. Maybe their ileocecal valve's off because of some brain issue, maybe not. But what they have is maybe an adrenal problem as well. But when you look deeper, you find out they've got this brain on fire, and the brain is firing so strongly that it gets fatigued, and the patient feels fatigued and doesn't realize it's their brain fatigue, and they blame it on something else in their body, low blood sugar, etc., toxicity or adrenals or whatever. And those things can be present, but the brain on fire and overfiring of the brain to exhaustion is very common, especially in your difficult patients. Let's talk about my other favorite nutrient, the amino acid cysteine. Cysteine is the sulfur-containing amino acid we've already addressed, rising from the sulfur amino acid pathway, starting with the essential sulfur amino acid methionine, coming down through homocysteine, getting converted into cysteine. We've already talked about problems where we don't get homocysteine converted down. B6, as you see right below homocysteine, is another issue we really haven't talked about in this pathway, but B6 can be necessary to convert into cysteine as well. Patients who have any trouble with this pathway, for the homocysteine pathway, so to speak, can have deficiencies of sulfur. The other thing can happen is you can use your sulfur up too fast. If you have not enough cysteine, for example, what could be the reason? Think about it. Why could you have not enough of anything? Your body doesn't make enough of it, or it breaks it down too fast. So this is the pathway showing how the body makes cysteine. If we don't have enough cysteine, it could be because the body doesn't make it, or it could be because it's breaking it down too fast. And what causes it to break down? Well, this driving it down into the sulfate pathway is one thing. There's a couple other pathways we need to discuss also. L-cysteine is a precursor to sulfate, as we've seen. Also, the most important substance, glutathione, is dependent on L-cysteine as a precursor. Taurine is also dependent on the cysteine as a precursor, and taurine plays a role as an antioxidant, converting free radicals to quenching free radicals into non-oxidizing forms, but also has an important neurotransmitter effect in the brain, very similar to GABA. These are important functions that cysteine is precursor for. And you'll see here that cysteine gets converted off to the right to glutathione. I wrote a paper called Glutathione, the most important molecule in the body. That's how I feel about glutathione. You don't have cysteine, you don't make enough glutathione. Again, taurine and sulfate are also coming from cysteine. So if you don't have enough cysteine, or if you're using it up too much in one of these other pathways, you may need to supplement it. Cysteine is usually required in homocysteine patients, at least temporarily, because if the patient has had all the inability to convert homocysteine past that point, they may be used up all their cysteine, so you have to supply them with cysteine at least temporarily. since the body's unable to produce it, nor its dependent substances. So if a patient needs more sulfate, more glutathione, more taurine, we may supplement cysteine temporarily at least, sometimes long-term, but at least temporarily until we get the folic acid, B12, etc. up to speed. Sulfate is necessary for coming again from cysteine and for cartilage production and repair. For liver detoxification phase 2, the steroid hormones, also catecholamines, epinephrine, norepinephrine, dopamine, and the other substances, aspirin, acetaminophen, ibuprofen, as we mentioned previously. So if we don't have enough cysteine, we don't have enough sulfate to be able to produce these, and cysteine is, in my opinion, the best substance to screen for sulfur amino acid pathways. And here we see again the need for sulfate in the production of cartilage. And here we see again the blow-up of the liver phase 2 detoxification, where sulfate on the left is one of the most important substances, along with glucuronic acid and the others. And liver phase 2 detoxification is a pathway for hormones and the other substances we mentioned. So steroid hormones are detoxified in phase 2 liver detox pathways by conjugation with sulfate molecules and also glucuronic acid, and something we've talked about in previous sessions and webinars. So the phase 2 detoxification pathway of hormones, if you want to supplement cysteine, supplement maybe 500 milligrams once, twice, 3 times a day, and that's an excellent source of sulfur, that is to say the L-cysteine. That's the source we use. And let me give you a case then. I had a 38-year-old healthcare professional come into the office as a new patient complaining of premenstrual syndrome for her entire menstrual life. The PMS symptoms started about 10 days prior to menses. Now, this is a very health-oriented person, a very healthy person. But we started testing. Didn't find a lot wrong. We did find there was a liver involvement. She needed sulfur, and she needed L-cysteine. So we supplemented her on L-cysteine. 500 milligrams QD, that's once a day, 500 milligrams once a day from the onset of her menses, once her flow started, to 10 days prior to her menses, which is 10 days prior was when her symptoms started. So from the start of her period up until where her symptoms would start, we gave her 1 500 milligram cysteine a day. At the time when her premenstrual symptom would start, 10 days prior to her period, we'd give that 500 milligram tablet BID or twice a day, starting 10 days prior to the period through the start of the flow. So one time a month to build up, 1 time a day during the non-PMS time of the month to build up the reserves, and then twice a day when she was actually making more hormones than she needed to have them detoxified, and that happened. She detoxified her hormones, no more PMS. So, the QA protocol, my favorite nutrients, where are they used? Folic acid, molybdenum, and cysteine, and the steps we discussed. They all have an individual significance. They all participate also, interestingly enough, in the so important sulfur amino acid metabolism and homocystinemia, and all are among the most common nutrients needed by patients. We'll say one more time, as I've said many times before, a patient comes into your office maybe with a tingling or a drawing in their hand. Maybe they come in with a back problem and they have a need for some disc issues and they need cartilage support. They need chondroitin and sulfate or something to help the body make that. They come with a shoulder problem and there's a relationship for sulfur in that case, maybe because of petrous major sternal involvement and the liver needing more sulfur. Or maybe it's because they can't make sulfate because they need molybdenum or whatever it is and they have an issue. They come in for some musculoskeletal problem. And when you follow a QA protocol going from systemic to local, they come in for this musculoskeletal problem and you identify problems wherein you save their life. Because you identify something like homocystinemia, which has chronic long-term degenerative effects. Maybe you don't save their life, but you prolong their healthy life by maybe 10 or 15 or 20 years by identifying these problems. These are huge things we have in our hands. These are huge tools that most people don't have a clue about, or if they do, they just shotgun and try to hope that they get a response on our patients. With the QA protocol, using muscle testing, manual muscle testing, and also indicator testing to prove our findings, we have the greatest tools in the world to help our patients with the things that they walk into our office with, whether they know about them or not. So, type in your questions. We'll make a few announcements. Kerry?
Thank you, Doctor. What a fascinating discussion. To order your QA Session 14 DVDs and get prepared for February, go to quintessentialapplications.com. You'll be taken directly there when you exit the room using the exit button up and to the right, or you can call Michelle at the number below. QA webinar recordings now available online through webinars supporting sessions 1 through 2. We got questions and comments. I'm going to take us back to the home page. You can click on the X in the picture, Dr. Schmidt's or my picture, to make us larger again. And let's go to these questions. I've noticed that in younger kids that 5-MTHF can really help them. Can you comment on this?
It says can really rev them up, I think. It can
really rev them up. That's right.
It's a little hard for me to read them.
Comment on this?
The reason for that probably is because of the effect on the catecholamines, the norepinephrine, epinephrine, and if they're deficient in the 5-MTHF and you give it to them, all of a sudden they're going to start to make these excited neurotransmitters. Also dopamine, which can have both excitatory and inhibitory effects. But that's a neurotransmitter issue. You might be trying to give them a little too high of a dose, so I monitor their dose closely. But then you have to start to look for nutrients to support inhibitory neurotransmitters such as GABA and so on.
If there are that many people that can't convert folic acid, is there any reason not to simply give everyone the MTHF form? I've had a few clients that test for folic B12 and end up having a reaction, getting a headache usually. Is it possible that due to the inability to convert that they really need MTHF?
I don't think it's a good idea to give anybody anything they don't need. We think we're pretty smart, but we really don't know about all the actions that take place in the body of excess things. There are studies which show patients who have excess folic acid have a greater increase to colon cancer and other cancers, for example. These are actually patients who are supplementing with dietary forms and maybe more synthetic forms of folic acid, in fact, where they're unable to be metabolized into the normal 5-MTHF form. But still, our knowledge isn't so great that I would just say give anything to anybody and give anything to everybody, I should say. So I would say test the patient. It's easy enough to do muscle testing, and it's easy enough to do indicator testing. By the way, when I have a child in the office, especially with their parents for the first time as a new patient, I do a lot of indicator testing, especially if they're unfamiliar with muscle testing, because it sometimes seems strange to them. So one of the things I find in a lot of kids that I see, because I'm seeing difficult patients, I'm seeing a lot of neurological issues, some brain damage and other kind of things in my practice as part of my practice. When I see these kids who have these issues, and the parents have probably been everywhere before they get to see me anyway, as many cases many of you, I always measure some kind of range of motion that they can see. I'll measure hip abduction, for example. Always looking for symmetry, not necessarily increasing range of motion, but trying to bring symmetry into the whatever range of motion I'm testing. And I'll use that as a test and test the folic acid against that so the patient can see, measure, see the indicator changing. The patient's parents can see it to see we really are finding what that patient's specific needs are. That actually helps to, very good to kind of make people understand the process that we're using, where we're using muscle testing but also indicator testing. And that happened because I see so many kids who need 5-MTHF because it's been missed by everybody else, that's one of the things I always do, is not just give it to everybody, but test to show the change in indicator function. As far as, you said you had a few clients that test for folic B12 and then having a reaction, getting a headache usually. Is it possible that's due to inability to convert and they really need 5-MTHF? Yes, that's possible. The dietary form of folic acid, the food form of folic acid is good, but sometimes certain supplemental forms of folic acid actually are of synthetic nature, and they can create problems with patients. So it may be they're having a problem with the folic acid or possibly the B12 type that you're giving them as well.
If methyl and adenosylcobalamin don't show a response in muscle testing, is it worth testing hydroxy and cyanocobalamin, or would you stop there?
Actually, I test methyl and adenosine first, and if I'm concerned about the patient's B12 status, I will then continue on to test hydroxy. I do test hydroxy, but I always start with methyl and adenosine, working my way back to hydroxy, and then cyanocobalamin. If a patient needs all of them and they respond to cyanocobalamin, give them that one because it will flood the pathway of cyanocobalamin and allow the body to make its own choices of the hydroxy, methyl, and adenosine balance.
Regarding MTHFR SNPs, I have found vessel care from Metagenics to be profoundly useful in many patients with significant challenges, homozygous or just significant clinical findings. I've had dramatic breakthrough results with patients using this product when the other MTHF products have only produced modest results at best, including migraines, depression, bipolar, neurogenic pain, etc. So that's a comment. Do you have any comment?
Yes, and I haven't used the Vessel Care product. I have used, as I mentioned, a variety of different 5-MTHF products. I'm not sure what it is about Vessel Care that makes it special. I'll have to look that up. But had patients who responded to, maybe I've tested just this last week, 8 different types of folic acid on one patient. I have 9 in my office. I tested 8, and only 3 of them actually work. So it may be the type of folic acid that makes the patient have the better effect. And there are also problems with many patients, especially if you start to mention toxic effects like migraines and depression and so on. They may be getting a response from some of the fillers or binders and excipients and so on. Maybe allergic.
Is there any I'm sorry. Is there any controversy with using the cyanocobalamin form due to the form itself? Cyanide derivatives?
Oh, no, not at all. In fact, thiocyanate is an essential substance in our bodies, and we need cyanide. Our body makes cyanide in very, very small forms, but in specific forms, such as the thiocyanate form. You would never give cyanide, of course, to a patient because it would kill a person, but in its pure cyanide form. But these chemical cyanide is combined with other substances, such as cyanocobalamin or such as thiocyanate, are essential substances for the body. And the cyanide without any combination is the poison. The other ones are natural substances, not to be worried about.
I've tested ionic molybdenum in the past and not seen much of a response. Is there a certain form that you recommend?
I will tell you, I've used ionic molybdenum. Ionic molybdenum is the product that worked for that nurse who had taken too much acetaminophen, for example. But I've also used other companies' molybdenums, Nutriwest, Biotics, Thorne, and so on and so forth, and many molybdenums. I test them because what I found is that the excipients in one may be a problem for a patient, as I mentioned earlier with the last question. But some patients respond better to one company's version than another. I've also seen with the ionic molybdenum for metabolics that has it's molybdenum chloride. There are some patients who are chloride sensitive. Those are often patients who have a problem with the Clorox test or the bleach sniff test we talked about in session 15 and QA step 7. But there are different molybdenums. I have probably 4 or 5 I test in my office, and sometimes patients only respond to 1 or 2 of those also. So try a different source, but the ionic molybdenum works fine, except on patients who have chlorine problems.
Unfortunately, we have a plethora of questions that we've already exceeded our time limit by a couple of minutes. If those questions are really pressing, please send them to qapplications@aol.com, and we'll try to get them answered for you in the future. Thank you so much, Dr. Schmidt. What an enlightening day we've had together. And we'll say goodbye to everyone at this particular point, and hope to see you all next week. Take care.